Hi guys, I hope all of you are doing good and enjoying my videos. So today I'm going to start a new topic called quadratic equations. Okay, so let's understand what are quadratic equations before you go ahead and try to solve problems. Understanding the concepts behind quadratic equations is very useful because it will help you to solve factorization problems very easily. Okay, so let's understand what are quadratic equations. So before this, right, till now, if you have reached to quadratic equations, right, prior to this you might have learned about linear equations. Linear equations are basically equations in one variable, right, where it will have only one solution. For example, if I take a linear equation, I can write a linear equation like this: 4x minus 8 equal to 0. If you look at it, right, there is only one variable, okay, and it will have a only one distinct solution. So when you go ahead and solve this, what do you get? 4x is equal to 8 implies x is equal to 2. Look at it. There can be only one distinct solution for this particular equation, right? That's why we call it as a linear equation. And if you want to plot the graph, right, for this particular equation, linear equation, right, if you want to plot the graph, suppose you have the graph this way: x, y-axis 1, 2, 3, 4, 5, right? Now look at it. What do you have over here? X is equal to 2. X is equal to 2 means x lies here. So basically the line is going like this. This is the graph for that particular line, right? That is what it indicates over here, right? So now when I come to quadratic equations, right, what happens is that a quadratic equation will have the degree as 2. Here the degree is 1, the power is 1. That's why we call it a linear equation, because it will always have one solution, one distinct solution. But in a quadratic equation, it will have a degree, the maximum degree is 2 over here. So the general form of a quadratic equation is this one. Okay, where A, B, C are real numbers. Remember, they are all real numbers. Okay, and the another condition is, and A cannot be equal to 0. A cannot be 0. If A becomes 0, right, this becomes a linear equation. Look at it, right? Similarly here, what is the general form of a linear equation? It is ax plus b is equal to 0, right? Again, A and B are real numbers and A cannot be equal to 0. If A becomes 0, right, this doesn't have any value. Look at it. So you don't have the variable. So here, if you look at it, the general form of a quadratic equation is this one: ax square plus bx plus c equal to 0. A, B, C are constants. And here, in this particular case, if you look at it, right, x will have two distinct solutions. Two distinct solutions. For example, let me take a very simple example, right? If I write a quadratic equation like this: x square minus 7x plus 10 equal to 0. So you will be able to go ahead and factorize this, right? If you go ahead and factorize, what do you get? You get x minus 5 and x minus 2 equal to 0. That's the factorization of this. Look at it here. And this is known as the product of 2 equal to 0. Now what happens is that when the product of two numbers, this is one number and this is a second number, when the product of two numbers is 0, we can safely assume that either x minus 5 is equal to 0 or x minus 2 equal to 0. Right? Either one has to be 0 or both can be 0. Then you are going to satisfy this particular equation. So what do you get over here? If you look at it, right, you get two values over here. X is equal to 2 and x is equal to 5. So if you want to plot this particular, if you want to plot this particular quadratic equation on the graph, right, x is equal to 2 is again the same straight line, and x is equal to 5 is again the straight line here. This is how it's going to go. Okay. So those are the two solutions for this particular equation, quadratic equation, right? Yeah. So now let's move on. Let's move on to understand how can we basically generate the use the general formula and find the roots. We basically call them as roots. Now I have told you that ax square plus bx plus c is equal to 0. If I want to find the values, suppose I say, if I say that let the roots, we call it roots in quadratic equation, or you can call it as solutions. Let the roots or solutions of x be alpha and beta. Okay, so what happens when you are going to solve this particular equation? You are going to get two values of x, like how I showed you earlier, right? When I solved a particular factorization problem, you got two values, 2, 5, right? Similarly, here this particular equation should have two values, alpha and beta. I'm taking them as alpha and beta for the time being. So now what happens over here? If I put alpha over here, right, it should satisfy the equation. If I replace x by alpha over here, right? If I put alpha, it should satisfy. It should give me that, it should, when I put the value of alpha over here, it should be equal to 0. Similarly, when I put a beta over here, plus b times beta plus c equal to 0. So they should satisfy. Whatever solutions I'm going to get in alpha and beta, they should satisfy this particular equation, right? So those are the two distinct solutions. Now, how do you find the values of those in terms of ABC? Here, if you look at it, right, A, B and C are real numbers and X is the variable over here. So now let's go ahead and find out the values of these two. How can you find out the values of these two? What are the values X can take, right? What are the values X can take? So what I'm going to do is that I'm going to take this particular equation, multiply throughout by 4a. Okay, this equation I'm multiplying by 4a. So what are you getting? 4a square x square plus 4abx plus 4ac. Right? Look at it. Just have some patience so that you can understand that why I'm trying to do that. I'm trying to basically find out the value for x. How to find out the value of x in terms of a, b, c. Okay? So now what I'm going to do is that use these two over here and convert this into a whole square. Okay, and this is a constant. Look at it, there is no variable over here. At least in these two terms, right, you have the variable, right? So I'm going to write it like this: 4a square x square plus 4abx, right, is equal to minus 4ac. I'm taking this on the other side, right? I have this term. Now if you look at it, can I write this one like this? 2ax ka whole square plus this one 2 times, I'll write it as ax, sorry, okay, I'll write it as 2 times ax times b. Look at it. If this is a for me, right, if I'm basically converting it to a whole square format, I'm making it as, like, if I say m, this is 2 times m into n. N is b. So I need to include a b square over here to make it whole square, is equal to, since I have included a b square over here, I have to include a b square on the other side as well. Look at it. These two b squares get cancelled out. I have introduced a b square on the left side. I have introduced a b square on the right side. So now look at it. This is in the format of 2ax plus b whole square is equal to b square minus 4ac. Make sense? Make sense? Okay. So now what I can do, there is a whole square over here. So what I can write? I can write it as 2ax plus b is equal to, this is nothing but plus minus root over b square minus 4ac. This is a square over here. If I take it to the other side, this will become the square root. And whenever you take a square root of a particular number, you need to include both the signs. For example, till now you might have learned that root 4 is 2. That is what you would have learned till now. But normally in the mathematical world, right, what do we do is that root 4 is both plus and minus 2. Okay, both satisfy this one. Why do they do that? Because if you look at it, if I do a square of plus 2, I get a 4. If I do a square of minus 2, I still get a 4. So that's why root 4 has a solution of plus and minus 2. Remember that one always. Okay, whenever you're doing a square root, you need to take both the values, plus and minus. So that is what I have done over here. Okay, same. Now what can I do over here? This is nothing. I can take b to the other side. So this becomes 2ax is equal to minus b plus minus b square minus 4ac, and x will become minus b plus minus b square minus 4ac by 2a. So if you look at it, right, x has two values over here. X is the variable which we started with in the quadratic equation, and I have converted the right side completely in terms of the constants. We had these constants a, b and c. So if they give you an equation, right, where you have, for example, we did this one just now, x square minus 7x plus 10 equal to 0. Look at it. What is a here? A is 1, b is minus 7, mind the sign over here, okay, and c is 10. So when you put these values over here, you are going to get x is equal to 5 and you are going to get x is equal to 2. So if you remember this particular formula, your factorization becomes very easy. Okay, so this is a key. This is one formula which is going to drive the entire quadratic equation chapter for you. Okay. So we have seen, right, we have calculated the value of x and we have got that it has two solutions. What are those two solutions? Look at it. We had both plus and minus over here. Write it like this. What is the first solution of x? What is the first value? We took it as alpha and beta initially when we started. Normally in the chapter of your quadratic equations, they'll always refer to them as roots, remember. Okay, they are called as roots. So if you look at it, the value of alpha is minus b plus of b square minus 4ac by 2a, and beta is minus b minus of minus b square minus 4ac by 2a. Okay, so those are the two roots. Now let's look at it. If this formula, whatever formula we have arrived at, right, does it work with that with that example what we have done earlier? We had this x square minus 7x plus 10 equal to 0. So what is the value of a here? A is 1. You don't have a coefficient. B is minus 7. Remember, it needs to be always always it has to be, for example, let me show you so that you don't get confused. Okay, your general equation is always ax square plus bx plus c equal to 0. So bring this one into the general format. How can I do that? Ax square plus of minus 7x times x plus 10. Look at it. Okay, did I bring it into the general format? Everything plus over here. So that's why I can safely assume that a is equal to 1, b is equal to minus 7 over here, and c is equal to 10. Right? So these are the values of ABC what we have for this particular equation. Now let's calculate the value of alpha and beta. What is alpha? Alpha is minus b plus minus b square. So minus of minus b, minus 7, it will become 7, plus you have a b square over here. Minus 7 ka whole square is 49, right? Minus 4ac. 4 into a into c. 4 into 10 is 40, right? 40 into 1 is 40. And 2 times a. 2 times a means it is 2 times 1, it is 2. Now look at it. What do you get over here when you solve this? 49 minus 40 is 9. Root over 9 is 3. So you get 7 plus 5 divided by 2. Sorry, it is 7 plus 3. Okay, 7 plus 3 divided by 2, which is 5. You got the first value, right? That is what we have got when we factorize that problem. Now let's calculate the value of beta. What is beta? It is again minus b. So minus of minus 7 will become plus 7. Minus again the same thing, b square minus 4ac will become 49 minus 40 divided by 2. Okay, so what do you get over here? You get 7 minus 3 divided by 2, which is 7 minus 3 is 4. 4 divided by 2 is 2. Look at it. These are the values which you got earlier when you factorize this particular problem. So this formula, if you remember, your life becomes very easy in quadratic equations. There is only one formula, and that's the formula. Okay, so it is minus b plus minus b square minus 4ac divided by 2a. That's the formula you have to remember for your life if you want to master this particular chapter. Okay, now let's move forward. Now, since we told that these are the two roots of the equation, right? The one here plays a crucial role, right? It will basically tell you whether you will be, what are the kind of roots you are going to get for a particular quadratic equation. This one is known as discriminant. This term is known as discriminant, remember. Okay, now look at it. How I'm going to explain it. If there are three conditions over here, it can take three different values over here. It can be if b square minus 4ac is equal to 0. If this quantity becomes 0, your roots, the roots, right? The roots of the equation will be equal. Both the roots will be equal. Both the values will be equal. Means if both the values are equal, what do you mean by that? It's a perfect square. Remember that one. You can the moment you see a quadratic equation, you can check this value. If it is equal to 0, both the roots are same. Okay, I'll take an example and solve it. Okay, so for example, look at x square minus 2x plus 1, right? Plus 1 equal to 0. Okay, x square minus 2x plus 1 equal to 0. What is this? This is nothing but x minus 1 ka whole square equal to 0. Look at it. So what do you get? There are two roots over here. X has a value of 1 and 1. Yes? Okay, so now let's check it by putting the value over here in this one. What is b? b is minus 2. So minus 2 ka whole square minus 4 times you have a 1 in A and you have a 1 in C. What do you get? You get 4 minus 4 equal to 0. Look at it. B square minus 4ac is equal to 0. That's why the roots are equal. Okay, this is a quick check you can do if you remember this one, so that your life becomes much more easier to find the roots of the equation. Next one, if b square minus 4ac is less than 0, if this value is less than 0, what will happen? The roots are imaginary, they are not real. The roots are imaginary, they will become imaginary. Because whenever you have a less than 0 value in this, for this particular quantity, right, it will become under root of a negative number, and negative under root numbers are known as imaginary numbers. Okay, so which are not real. Remember that. So for the time being, whenever you see a value is less than 0, you should go ahead and write that the roots, there are no real solutions for that particular quadratic equation. Understood? Okay, good. Okay, next one, if b square minus 4ac is greater than 0. If it is greater than 0, both the roots are real. Both the roots are real in nature and not equal. They'll not be equal. Right? In this particular case, what happened? When it is equal to 0, they are real. They are definitely real numbers and they are equal. But if it is greater than 0 over here, greater than 0 means you can get a root 5 over here. Right? Root 5 is a, what do you say? Root 5 is a irrational number. So you'll get the root in the form of a surd. Right? But it's still real. But they are not equal. Remember, they will not be equal. For example, if you have one root as 2 plus root 3, right? The other root will be definitely 2 minus root 3. Okay? In the world of irrational numbers. That's how it works. Okay? So remember this concept well so that it helps you to solve problems very easily. Okay? So b square minus 4ac is known as the discriminant. Just by evaluating this value, you'll be able to get to know that what are the roots going to come out to be. And you can tell upfront by looking at the quadratic equation whether it is solvable or not. Okay? Right. Okay. So another thing which you need to remember is the sum of roots and product of roots. So let me explain that. Okay. So we had the two roots as alpha plus beta, right? Alpha. So you had alpha is equal to minus b plus of b square minus 4ac divided by 2a. And you had beta is equal to minus b minus of b square minus 4ac divided by 2a. So these were the two roots. When you do this, right, x minus alpha into x minus beta, like this, right? When you multiply these two, you are going to get that equation, the general equation. This is what you are going to arrive at. You are going to get that because these are the two roots, right? This is how you are going to get. Now, how if the roots are given to you, and you want to basically write the, they ask you, they give you the roots, they give you the values of alpha and beta, they ask you to basically give you the quadratic equation. So suppose they have given alpha is equal to 2 and beta is equal to 5. How are you going to find the quadratic equation? So simple, what you need to do? You need to do x minus 2 times, because this is the root, and x minus 5. When you multiply these two, you get the same equation. So this is the equation. Right? This is the equation. This is the reverse way of finding the quadratic equation if the roots are given. So now to easily find without multiplication, what do we do is that there is a concept called sum of roots, which is nothing but alpha plus beta, and there is a concept called product of roots, which is alpha times beta. Okay, now can you find out alpha plus beta? Yeah, add these two. If you add these two, what do you get? Look at it. If you add alpha plus beta, what do you have in alpha? You have a minus b plus b square minus 4ac by 2a plus, I am doing a plus beta is how much? Minus ba minus b square minus 4ac by 2a. Look at it. LCM is same in both the cases. Now look at denominator. This discriminant completely cancels out. So what are you left with? You are left with minus b, which is minus 2b. And you have a LCM minus 2a. So it becomes minus b by a. So remember, alpha plus beta is always minus b by a. Okay, you got the sum of the roots. You need to remember that. Okay, so that you can easily frame the equation. Okay, now product of roots, multiply these two quantities, alpha, beta. You have to multiply this with this. When you multiply that with that, what do you get over here? Look at it. This is a minus b, this is a term, and this is a term. This is one term and this is one term. Look at it. It's in the format of x plus y, x minus y, right? X plus y, x minus y. When you multiply x plus y and x minus y, what do you get? You get x square minus y square. So this will become minus b ka whole square minus of root b square minus 4ac ka whole square divided by 2a into 2a will give you 4a square. Got it? See, look at it. Now x open up. What do you get? You get a b square over here. Okay? And this will become, this root gets cancelled out. So you're left with b square plus 4ac divided by 4a square. B square gets cancelled, 4 gets cancelled, 1a gets cancelled. So you're left with c by a. Okay, so what did you get? Product of roots. Product of roots is c by a. Okay, remember this one. Why I am telling you to remember this one is that if you know these formulas well, these three things, you will be able to do problems much faster. Okay, so now look at it. Now, if they have given you the roots, individual roots, you can directly write the quadratic equation. But there is a format of writing the quadratic equation if you have the sum of roots and product of roots. The formula is this one. It is x square plus alpha plus beta times x plus alpha beta is equal to 0. Look at it. Okay, this is what it is. If you have the values of alpha plus beta and alpha beta, you can directly put it and get the answer. Okay, so if you see here, right, this is nothing but this is an expansion of that one. Look at it. It is x plus beta equal to 0. Look at it. Got it? Okay, so